Hi friends, welcome back to my channel all about science, and today I'm here with a brief discussion about topic kinematics. And as you know guys, it is also the branch of physics. And so let's get started. Well guys, what is kinematics? So, guys, it is the branch of mechanics which deals with motion of objects without the reference of force which causes motion. Well, guys, mechanics is one of the branch of physics, and mechanics consists of two other further branches, which are kinematics and dynamics. Right now, with you people, I'm going to discuss kinematics. Well, move forward. In kinematics, if we see rest and motion are the main topics. Well, what is rest? Rest. A body is said to be in rest if it does not change its position with respect to its surrounding. You can see in the picture below that all these things are in a rest motion. Well, come forward to motion. A body said to be in motion if it changes its position with respect to its surrounding. Well, in the picture you can see a bird flying, a parrot also flying, man walking. So these are the examples of emotion. And over there and on the left hand side you can see a tower, building, tree. These are non-living things. They are in a rest motion. We can also take the example of a car, a moving car, and a uniformly car which is in constant motion, which is not moving. It is uniform position. It is having uniform position. Well, let's move to our end the topic. Types of motion. Translatory motion, number one. Number two, rotatory motion. And number three, vibratory motion. Well, let's see what translatory motion is. Well, guys, translatory motion. Translatory motion is when all the points of a moving body move uniformly along the same straight line. Such motion is called translatory motion. Well, guys, when all the points of a moving body, just like take the example of a bus, it is moving towards its path. That means it is moving straightly. Okay, and the road is not having any type of direction like zigzag one. The road is having straight direction. That's why it is moving in a straight direction and equally along the same straight line. Obviously, I've told you before. Okay, and such and this motion translatory and this translatory motion is known is that's why it is called as translatory motion. Well, there are three further types of we can say motions, and that are linear motion, circular motion, and random motion. So let's get into that. Well, linear motion. What is linear motion? Well, motion of a body along a straight line is called linear motion. And you can take the example of an artificial satellite. When it moves in a straight line. When it moves its body, its motion is in its straight line, and that's why it is known as linear motion. Well, come on, circular motion. Take the example of Earth or the example of moon and sun. The moon is circulating around the sun. Okay, and the Earth is also circulating. Yes. Well, this is known as circular motion. Random motion, the third one. We also say it as Brownian motion because in our childhood or in our past, we people have studied that Brownian motion. Brownian scientist uh, observed some pollen in the water, and then he gave that theory as Brownian motion. So that's why it is known as random motion or as a Brownian motion. Irregular motion of an object is called random motion. Okay. Um, The zigzag motion, or just up and down and right and left motion in just a particular time, is called random motion. Well, now rotatory motion, which is the type number 2 of motion. The motion of the body around a fixed axis which passes through body itself is called spin or rotatory motion. Well, we can take the definition or the example of Ferris wheel. Ferris wheel, which was in Aladdin, you people have seen, it was just moving round and round and round in its fixed axis. It is not moving forward, neither it's moving backward. It's just in its uniformly constant position in its fixed axis and moving around just in a circular motion. This is known as the rotatory motion, or you can take spinning top example also. Well, let's come to vibratory motion. Well, guys, let's see what vibratory motion is. Back and forth motion of a body about its mean position is called vibratory or oscillatory motion. Well, guys, oscillatory or vibratory means a vibration, or we can take the example of pendulum or ball and ball, example of simple harmonic motion. And these are all the examples of simple harmonic motion, which is related to vibratory motion and oscillatory motion. Clock's pendulum is also the example of it. And a child, if a infant, or we can say a child, is swinging a swing, it is also known as a vibratory motion. There are many examples. We cannot even find them or even though count them. Well, guys, now we are going to describe more about motion. So, the motion of an object can be described by specifying its position, change in position, speed, velocity, and acceleration. Well, guys, specifying its position and change in position means that we are going to describe the motion which changes its position and the motion which is still in constant position. Okay, well, speed, velocity, you people know very well from the childhood. Everyone knows that. Well, let's see. Displacement and distance are the first. I'm going to tell you. Firstly, then next topic are going to come. So, distance and displacement. Well, distance is measured in straight line, the distance which is measured in a straight line in a particular line means, as I have told you before, that the road is not in a zigzag position, it is always in a straight position. It is having U-turns also, and one way two ways also, but is having straight way. Okay, not a zigzag one. So the distance measured in the straight line. A person is moving on, and a person is driving his car, and he is moving straightly in or straight, or we can say it as a road, as a straight line or a particular line, and this is known as displacement. Well, displacement is a vector quantity, and its SI unit is meter. Whenever we do its numerical and its conversion or anything such like that, we use meter for displacement. Okay, guys, welcome to while distance, the total length covered by a moving body without mentioning direction of motion, is known as distance. They are saying over here that the total length covered, if a car is moving, okay, and it is not having any direction of motion, and it is just moving in just a straight path without any type of direction or something like that, is known as distance. Okay, and it is an scalar quantity, and its SI unit is meter. Okay, whenever we do the numericals of displacement, or just like speed, velocity, acceleration, distance, we use meter just for distance and displacement. Then we are going to study more for the SI units for speed, acceleration, and velocity. Well, let's come to speed. Distance covered by an object in a unit per time, or in a unit time, or a time per unit is like that. A unit time is called speed. Okay, whatever work we do in our daily life, and whatever work we do it on the basis of time. Time is the thing or which moves on the principles of speed. Okay, and over here they are saying that the distance covered by an object, just like, just take the example of car. It is moving, and it take one round of a ground in just 2 minutes. So this is, or 1 minute. So this is called speed. Okay, and we are having the formula of speed as distance traveled upon time taken. Whenever we do any type of numerical for speed, as I've told you earlier, we use this formula, and we use meter for okay, and meter per second is used for speed, and speed is a scalar quantity. It is not a vector quantity, it is a scalar quantity. Well, let's come to velocity. The rate of change of displacement with respect to time is called velocity. So guys, over here that they are saying that velocity means speed of an object in a certain direction, and it is rate of change of displacement. There is something change in the displacement which is following the principles of time or speed is called velocity, and its formula is v equals to delta t d upon t. It's like d is for the change in displacement, delta is for delta t. Velocity equals to change in displacement upon time taken. Well, and its SI unit is meter per second, because sometimes in some numericals, in some equations, or in some derivations, we use v instead v, which is the short form of velocity, which is used for velocity. We sometimes in place of speed we use velocity, or in sometimes place of velocity we will use speed. So just like in speed topic, you see speed equals to distance upon time taken, so its formula is v equals to s upon t. S is for distance traveled, t is for the time taken, and v is for the speed. Okay, well, uniform velocity, you people know what uniform velocity is. A body is said to have uniform velocity if it covers equal distance in equal interval of time in a particular direction. That means that they are saying over here that if a body is in its uniform or equal velocity, and it covers equal distance in equal interval of time is in a particular direction, just like a car is going in a particular direction. Okay, and it covers equal interval of time and equal distance, just like it moved 2 km it moved 2 km in 3 to 4 minutes, or might be more than that. So this is known as uniform velocity. Well guys, now acceleration. Rate of change of velocity of an object with respect to time is called acceleration. Now guys, over here they are telling us that the rate of change of velocity, now this time they are talking about velocity, not the displacement, of an object with respect to time is called acceleration, and it is having its formula as acceleration equals to change in velocity upon time. And it its SI unit is meter per second square, not meter per second, just not meter per second, it's meter per second square. Well guys, I hope that you people would have understand all those basics of motion and the types of motions and all those things which I've described about motion and the topic kinematics. And as it is the branch of mechanics, mechanics is having two main types which are dynamics and kinematics. Inshallah, in next video I'm going to just explain you about dynamics. Guys, bye bye, and don't forget to like and subscribe.